Okay, so this last problem is one where you have to do a little bit of thinking. So here I've got two electric charges that are 2.5 meters apart on the x-axis, so they're on a horizontal line. Q1 is at the origin, so x equals 0, and it has a charge of negative 9 nanocoulombs. Q2 is at 2.5 meters, and x has a charge of plus 3 nanocoulombs. So let's first draw this. So this is what we... Alright, so let's put in Q1, which is negative. Let me get rid of my line in there. All right. Q1 is negative, and Q2 is positive, and the distance between them is 2.5 meters. Okay, and I want to know, is there any point in space where the total electric field is 0? So what I'm going to do is, I'm going to imagine I have a little positive charge. That's my little red dot. I'm going to put it in different places and see what the net electric field is. So that means the electric field from 1 and 2 added together. So let's think about it. So electric field from 1. So I'm going to be at the point where I've got this red dot. I'm going to think about, for the electric field, what direction would the force on that little positive charge be? Well, it's going to get sucked towards Q1, and it's going to get pushed away from Q2. Okay, so at first glance, it looks like we've got forces in opposite direction, so they could possibly cancel out. And we'll come back and think about that in a minute. Or how about if I put my charge somewhere in between the two of them? If I go in between the two of them, remember my little red dot is a positive charge. It's going to get sucked towards the negative charge, and it's going to get repelled away from the positive charge. So now if I look at those two vectors here, these will never cancel because they're always in the same direction, so they're always going to add up to give a net electric field. So in between the two of them won't work. How about if I go on the far side? So I'll go on the right side. Now I'm going to get my E2 is going to be pushed away from charge 2. E1 is going to get sucked towards charge 1 because charge 1 is negative. The field goes into it. So looks like there's two possible places where E2 and E1 are in opposite directions, and so they could cancel out. What if I go anywhere off the line? If I go anywhere off the line, then my two vectors won't be in the same line as each other, and there'll be no way that they can ever add up to 0. So I can't be anywhere off the line. I have to be somewhere on the line. All right, so now let's look at the sizes of them. All right, so E2 is going to be K Q2 over R2. E1 is going to be K Q1 over R1. All right, so Q1 is 9. So let's put in some numbers, and I need to, of course, square my distance. All right, so K is 9 times 10 to the 9. Q2 is 3 nano 10 to the minus 9 over R2 squared. So that's going to be 3 9s is 27. And 10 to the 9 times 10 to the minus 9, that cancels out. So I've got no powers of 10. So I've got 27 over R2 squared. And E1 will be 9 times 10 to the 9 times 9 times 10 to the minus 9 over R1 squared. So that's going to be equal to 81 over R1 squared. And again, because I'm just finding the magnitude, I took away the negative sign that was in front. So what I've got, whether I'm on the left side of Q1 or on the right side of Q2, I've always got these two cases where I've got 27 over R2 squared for E2, and E1 is 81 over R1 squared. And if they're going to cancel, then I need to have those two equal to each other. So 27 over R2 squared has to be equal to 81 over R1 squared. Okay, so those are only going to be equal if R1 is bigger than R2. So the distance between my point and R1 has to be it has to be bigger than R2 because I want those two to be equal. And so if I look at a point on the left, let me go to a different color. So that's my R1 and that's my R2. So if my test point is on the left of Q1, R1 is always less than R2. Okay, so in that case, it doesn't cancel. All right, let's go to another color. Let's go to green. What if I'm on the right side of Q2? Now my R2 is the distance between my red dot and Q2. My R1 is the distance between Q1 and my red dot. So now R1 is greater than R2. So in this case, they can cancel. Okay, so for my answer for part A is yes, there's a point and it's going to be to the right of Q2. All right, so part B now asks, okay, so you know that there is a point over there. Where exactly is it? Well, it's going to be at the point where this equality is true. So let's cross multiply. So I'm going to multiply that one up there and that one up there and do some math. So 27 times R1 squared has to be equal to 81 times R2 squared. And let's see what we got. These all have a factor of, let's see, 81 is divisible by 27, so that means R1 squared is equal to 81 over 27 R2 squared. So R1 squared has to be equal to, if you put that in your calculator, you can see that's 3 times R2 squared. Okay, so I've got to have R1 squared equals 3 times R2 squared. All right, so when will that be true? So I got to figure out what is my R1 and what's my R2. So I'm going to scroll this up a little bit, and I'm going to draw another picture because we're told in the problem the coordinates of them. So let me draw another picture. So Q1 is at x equals 0. Q2 is at x equals 2.5. And then I've got my other point here. I want to know the x location of it. So let's call that x1, x2. And what I'm trying to find is I'm trying to find that distance there, which is x. And so x is actually equal to my R1, right? It's the distance from my point where x equals 0, which is R from Q1, out to where my point is where the field is equal to 0. So x equals R1, that's what I'm trying to find. And it has to satisfy the condition that it's 3 times what R2 is. So what's R2? R2 is going to be equal to that distance there. And that distance is going to be equal to R1 minus 2.5 meters, because what we have is 2.5 meters from Q1 to Q2, and then R2 distance further. So R1 is equal to R2 plus 2.5 meters. Okay, so I want to find what my location is. I want to find what my R1 is. So let me rewrite. R2 is equal to R1 minus 2.5. So now what I've got, if I plug that into my equality, is R1 squared is equal to 3 times R1 minus 2.5 squared. And then it's just a matter of doing the algebra. So I'm going to expand out that square. So R1 squared is equal to 3 times, now square the first term, R1 squared, minus 2 times 2.5, so minus 5 R1 plus 2.5 squared, which is 6.25. Okay, so R1 squared is equal to, multiply through my 3 times R1 squared. And then I got 3 times 5, so minus 15 times R1. And then I've got 3 times 6.25, so that's 18.75. And now I'm just going to solve it for R1. So in order to solve it, I'm going to get myself a little bit more room. I'm going to bring all the terms. I'm going to do a squared, ax squared plus bx plus c equals 0 and use the quadratic formula. So I'm going to bring this other term over to that side. So what I get is 2r1 squared minus 15r1 plus 18.75 is equal to 0. So a is equal to 2, b is equal to minus 15, and c is equal to 18.75. Okay, so what's my solution to the quadratic equation? Is x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. All right, so a is 2, b is minus 15, c is 18.75. So I got negative b, so plus 15 plus or minus the square root of 15 squared minus 4 times 2 times c, which is 18.75, divided by, on the bottom, 2a, so divided by 4. Okay, and if I plug that into my calculator, I get 15 plus or minus the square root, and if I put all that number into my calculator there, I've got 15 squared minus 4 times 2 times 18.75. So I get 15 squared plus or minus the square root of 75 over 4. So square root of 75 is 8.66, so 15 plus or minus 8.66 over 4. So if I put my numbers in there, I get 23.66 over 4. For one of my solutions, which is 5.91 meters. For the location, or if I use the negative, that's the positive solution. If I use the negative solution, I've got 15 minus 8.66, so it's 6.34 over 4. Which is 1.585, and that is in between. So at this point, this is also a location where R1 is 3 times R2, but it's in between the two charges, so that's up in the region where the two charges are pointing, the two fields are pointing the same direction, they don't cancel. So this solution is not a possible solution. And so the only solution in the right region is at a distance of 5.91 meters away.